This integral is going to make you fall in love with calculus. So make sure you watch this video till the end. In order to simplify this, what you do, you either convert this function in terms of tan or convert it in terms of cot. Okay, so you choose one and do that conversion. Let's see if I convert it in terms of cot. So I can write that tan x as 1 divided by cot x. So I have 1 divided by square root of cot x plus square root of cot x, and we are integrating this with respect to x. Now, in order to simplify this, let's do a cross multiplication here. So we have integration of 1 plus square root of cot x multiplied by square root of cot x is cot x divided by square root of cot x. Again, we are integrating with respect to x. Okay, now that 1 divided by square root of cot x, okay, that square root of cot x in the denominator can be written as square root of tan x in the numerator. So I have square root of tan x and 1 plus cot x, and obviously I'm integrating with respect to x. Now, in order to simplify this, we'll have to do a u substitution. What u substitution will do is we'll have to get rid of that square root, okay, in order to simplify this. And in order to get rid of that square root, what we'll have to do is we'll have to put tan x is equal to u square, because once you put tan x is equal to u square, that square root will get cancelled. Okay, so let's do that substitution. Tan x is equal to u square. Once you do that substitution, we'll now have to convert that entire integral from the x world to the u world. That means we'll also have to convert that dx in terms of du. In order to convert that dx in terms of du, we'll actually have to find the value of dx. And in order to find the value of dx, let us find the value of x first. From here, we can say that x is equal to tan inverse of u square. Okay, now in order to find the value of dx, let us differentiate both the sides with respect to x. So you have, therefore, dx is equal to, now remember that the differentiation of tan inverse of x, so if you have differentiation of tan inverse of x, it is nothing but 1 over 1 plus x square. Okay, so differentiation of tan inverse of u square is nothing but 1 over 1 plus u square square, and then by chain rule you'll have to also differentiate u square, which is 2u and du. Okay, I hope that made sense. So the value of dx from here, eventually what you will get is dx is equal to 2u du divided by 1 plus u to the power 4, and that's the value of your dx. Now we can substitute those values here and convert this entire integral from the x world to the u world. Also remember that the cot x here, since tan x is u square, we can say that cot x is nothing but 1 divided by u square. Okay, so now let's see what do we get when you convert that integral from the x world to the u world. So our integral will become square root of tan x will become square root of u square, and then we have 1 plus cot x, so 1 plus 1 divided by u square, and then instead of dx you can write 2u du divided by 1 plus u to the power 4. I hope that made sense. Now, in order to simplify this first of all, this 2 is constant, can be taken out of the integral. So you have 2 times integral of, and the square root of u square is nothing but u, and that u multiplied by this u over here will just give you u square. Okay, and times you have 1 plus 1 over u square. Okay, and then you already have 1 upon 1 plus u to the power 4 with respect to u. So now you can simplify this by multiplying this u square inside of that bracket. So you have 2 times integral of u square times 1 is u square plus u square times 1 over u square is 1. Okay, and in the denominator you already have 1 plus u to the power 4 or u to the power 4 plus 1, and you are integrating with respect to u. Remember that whenever in integral you see a function of the form u square plus 1 divided by u to the power 4 plus 1, what you have to do is you have to divide numerator and denominator by u square and get rid of that u to the power 4 actually. Okay, so you have two integral of, so we'll divide numerator and denominator by u square. What that will help us is we'll get rid of that u to the power 4. Okay, so u square divided by u square is 1. Divide everything with u square. 1 divided by u square is nothing but 1 divided by u square, divided by u to the power 4 divided by u square is u square plus and 1 divided by u square. I hope that made sense. I'll put a bracket and we are integrating with respect to u. Now, in order to integrate this, what you need is a little bit of observation. What observation you need is, if you notice the numerator, whose differentiation will give you this function 1 plus 1 over u square. If you think about it, that function is actually u minus 1 by u. If you differentiate this function, you actually end up getting 1 plus 1 over u square. How? Let's see. Differentiation of u is nothing but 1 minus, and differentiation of 1 over u is minus 1 over u square. So we get 1 plus 1 over u square. So that means the differentiation of this function u minus 1 by u is nothing but 1 plus 1 over u square, okay, which is this numerator. How that can help us is, if you are able to bring u minus 1 over u in the denominator, the differentiation of that u minus 1 over u is already present in the numerator. Okay, so we can simply do a u substitution and simplify that integral further. How do you bring that u minus 1 by u now in the denominator? We can use a simple formula of algebra, which is a square plus b square can be written as a minus b the whole square plus 2ab. Okay, so with this formula of algebra, we can simplify this denominator and write it in terms of u minus 1 by u. Let's see how do you do that. So we have 2 times integral of 1 plus 1 over u square divide by, so here we can apply a square plus b square. So we have a minus b the whole square. So u minus 1 by u the whole square. You see how we were able to generate that u minus 1 by u plus 2ab. So plus 2 times u times 1 by u. Okay, and obviously we are integrating with respect to u. How simply we were able to generate that u minus 1 by u in the denominator. This u and this u will get cancelled. Okay, now we have 2 times integral of 1 plus 1 over u square in the numerator. In the denominator, we have u minus 1 by u the whole square plus 2, and we are integrating with respect to u. Now, since we know the differentiation of u minus 1 by u is nothing but 1 plus 1 over u square, what we can do is we can do a substitution of u minus 1 by u. So let's say we put u minus 1 by u is equal to t. Okay, now in order to convert that integral from the u world, we'll have to convert it to the t world. And in order to do that, we'll differentiate both the sides with respect to u. So differentiation of u is 1. Differentiation of minus 1 by u is plus 1 by u square is equal to dt by du. Okay, now if you notice here, we need 1 plus 1 over u square times du. So you can actually multiply that du on the left hand side, and you get 1 plus 1 by u square multiplied by du is equal to dt. So now let's convert that entire integral from the u world back to the t world. Okay, so this thing in the numerator, 1 plus 1 over u square times du, will become dt, and this will become t square plus 2. Okay, so we have 2 times integral of dt divided by t square plus 2. Now it is so simple to integrate. You can just write that 2 as root 2 square. So we have 2 times integral of dt divided by t square plus square root of 2 square. Now we know that integral of 1 divided by x square plus a square with respect to x is nothing but 1 over a tan inverse of x over a. So we can actually apply that formula over here to integrate this. So we have equals 2 times. So we can 1 over a. A is here root 2. So we have 1 divided by root 2 tan inverse of x over a. So here we'll have t divided by root 2 plus, let's add the constant of integration c. We'll now have to convert that integral from the t world to the x world. But before that, let's convert it into the u world. Remember that the value of t that we had substituted was u minus 1 over u. Okay, so we can substitute that and we get, remember 2 divided by root 2 is nothing but root 2. So we have square root of 2 tan inverse of u minus 1 by u divided by square root of 2 plus constant of integration c. Remember that we had u square is equal to tan x, which means that u is nothing but square root of tan x. Okay, so we can make that substitution. Instead of u, we can just write square root of tan x, and let's see what do we get as our final result. So we have square root of 2 tan inverse of square root of tan x minus 1 divided by square root of tan x is nothing but square root of cot x divided by square root of 2 plus constant of integration c, and this is nothing but the final result of the integral of square root of tan x plus square root of cot x. How easy and efficient that integral was when you use the right technique. If you understood the concept that I taught you, and if you like this video, please do consider to subscribe to my channel. I do post math and calculus content every single day. If you want to master calculus, hit that subscribe button. I'll see you tomorrow.